So can we really destroy a star? That's an excellent question that came up during our last poll. The top response was yes, by turning it into a black hole. And that's actually one of 4 options we have. So let's see how it works in theory. And this may sound like science fiction, but there's real science behind it. Like how scientists recently created a miniature star to better understand their behavior. They did this by smashing 2 giant laser beams together in a device called the Omega Laser Facility at the Lawrence Livermore National Laboratory in California. These lasers focus the intense heat and pressure needed to fuse hydrogen atoms into helium, just like in a star. This synthetic star lasted less than 100 millionths of a second, but long enough to help researchers validate computer models of stellar interiors. It was also about 10 trillion times smaller than our Sun. But what if we want to destroy a star? Well, the first option is to starve it. Option 1, star lifting. How? Use magnetic fields or nanobots to strip away a star's hydrogen, the fuel that makes it shine. Why? Harvest resources for a Dyson swarm. Horror angle. The Sun screams as its flesh is peeled away. Honestly, though, the more I think about it, the more I realize that my horror angle is actually more for options 2 through 4. This one would be more like an eldritch cosmic horror. Imagine a Dyson swarm eating away at your ship as you try to fly through it. Okay, so option 2 is to force the star to go supernova. We could do this by injecting strange matter into the star's core or dropping a tiny black hole in there. Either way, the result would be the same. It would cause the star to explode much earlier than it naturally would, which means we can observe a supernova from a safe distance. Why? Clear space for a hyper-advanced civilization, possibly as a weapon. Sci-fi example, the Death Star, but with physics. Horror angle. As the star collapses in on itself, all matter is consumed by the singularity until only light remains. Then it explodes outward as a supernova. But now the radiation has nowhere to go, so it blasts out into the universe, searing everything in its path. This brings us to option 3. If we really want to clear everything out of a solar system, we could use a bomb. But not just any bomb. A black hole bomb. First, we take a small black hole and attach a powerful engine to it to make it accelerate faster than anything in the system. Then we put a big block of antimatter in front of it. When the black hole hits the antimatter, they annihilate each other, releasing even more energy, making the black hole go faster. Eventually, the black hole will hit the star and engulf it, adding the star's mass to its own. This sudden increase in mass causes the black hole to release a tremendous burst of energy, a gamma-ray burst, which will blow apart the entire solar system. Why? To erase a solar system perfectly. Cosmic horror. A silent flash. Then the galaxy's arm goes dark. But those are only 3 ways. There's another way, too. One that will require technology far beyond our current capabilities, but the reward will be worth it. We can completely reset reality itself. Option 4, false vacuum. How? Use a quantum trigger to destabilize spacetime near the star. Why? You hate all stars. We could potentially collapse the star without destroying the surrounding planets. Wait, what? Yes, it's complicated. Just hear me out. In quantum field theory, the vacuum of space, the seemingly empty region between stars and galaxies, is actually a frothing sea of virtual particles constantly popping in and out of existence. This is known as the quantum vacuum. Now, while we normally don't notice these virtual particles because they are too small, they can become real under certain conditions. This process is called pair production. If a photon with a high enough energy passes close enough to a massive object, like a star, it can split into an electron and a positron. But here's the thing, the universe doesn't know how much energy a photon needs to make this happen. All it knows is the minimum amount. So if we were to somehow make a photon that had a lower amount of energy required to make a virtual particle real, then we could make particles appear anywhere we wanted. It wouldn't even need to be very big. We could start with something small like a duck. But if we made the energy level low enough, then the duck could become a star, or rather a new star. It would replace the old star exactly as it was, but now it would have a slightly different quantum state. So then we could keep going down the list of ducks, replacing every particle in the star with a new version of it until we got rid of the original star entirely. But wait, you might say, where does the new star get its energy from? Well, that's the thing. It doesn't need any energy. It already exists. This may seem like a cheat, but according to the math, it should work. The hard part is figuring out how to make this hypothetical energy level possible. Some physicists believe that it might be possible to achieve this state by creating a large bubble of nothing around a star, a region of space where normal rules of physics don't apply. This false vacuum would act like a wormhole, allowing particles to pop into existence inside the bubble and then escape back into the normal universe as real particles. If we could create this bubble around a star and make the energy levels low enough, then we could essentially suck the star dry, turning it into a black hole. But this is all theoretical. And honestly, it seems highly unlikely that humanity will ever be able to achieve this feat, especially since if we were to create a false vacuum around a star, it might end up collapsing the entire universe instead. Existential risk. The universe forgets fusion ever existed. Now, I'll admit, the concept of blowing up a star with a black hole bomb sounds pretty cool. But I think the true power of the hypothetical ability to destroy a star lies in its subtlety. Imagine the possibilities that come with being able to remove the fuel source of a star or change the rules of physics near it. It's not just about brute forcing a solution. It's about understanding the underlying principles and finding creative ways to manipulate them to your advantage. Like and subscribe for more science facts and what IFS.